So we're in the last section of Unit 9. We're actually on page 45. And we're going to just talk about some word problems that end up with quadratic equations that we end up needing to solve. So this is nothing new, but basically it's an extension of applications of quadratics. So we'll work maybe the first couple examples in this video, and then I'll break the rest of it up into maybe a couple more videos. So you can read this. I'm not going to read it to you, but basically this is another one of those crazy formulas that somebody came up with for the scenario that these teams, if there's T number of teams and they play each other twice, then the total number of games played can be calculated using a formula. So basically, when you're given a formula, you need to really understand what the variables stand for. Now, usually the variables are what we call intelligent variables, meaning the letter that the variable is used goes with the word that it stands for. So in this case, T is equal to the number of teams that are playing in this league, and G stands for the number of games they play. So that's good, because T and T and G, we can get that figured out. So the formula is the number of games equals the number of teams squared minus the number of teams. And they're asking us, they're saying, okay, we're playing a total of 72 games. How many teams are there? So we're going to solve for T is the basic idea here, if we plug in 72 for G. So now this is what our equation looks like. It's quadratic because we have an exponent of 2. We're going to solve it, but the first thing we need to do is get this equation equal to 0, not 72. So we're going to subtract 72 from both sides, and now we have our equation in standard form, and we're ready to factor it. You could use the quadratic equation to solve it. Obviously, we have an A, a B, and a C. Factoring, generally, when something will factor, is a little bit easier. We can't use the square root because we don't have two terms where we can take a square root. So our choices are the quadratic equation or factoring, and I'm going to factor. So I'm going to use the AC method. I'm looking for two things that multiply to 72 and add or subtract to -1. And what comes to mind, to me, is 9 and 8. And let's see, this is -1, so we would need a -9 and a +8. So if you can just see it right off the bat, then you don't need to go through the whole process of listing all the factors. So if we use -9 and 8, we're going to have T minus 9, and we are going to have T plus 8. Now, I skipped the step in here where you split up the minus T. If you want to see it, remember it would look like this. 0 is equal to T squared plus 8T minus 9T minus 72. And then you take out your common factor. 0 is equal to T plus 8 minus 9 plus 8. So the T minus 8 is your common factor, so it's T plus 8, and what's left is the T minus 9. If you can go directly, like I did, from here to here, you don't have to do this middle step. Really, the middle step is really more beneficial in my mind when you have a coefficient in front of the squared that's something other than 1, because then sometimes it's a little bit harder to see what your factors are. So I'm going to use some of this space down here. Now that we've got these two factors, in order to solve for T, we set T minus 9 equal to 0 and T plus 8 equal to 0. Remember, we're going to have two answers. When you have an equation that's got an exponent that's something other than 1, you're going to have as many answers as the exponent. So if we had a cubed here, we'd have 3 answers. So T is equal to 9. Add 9 to both sides, and T is equal to minus 8. So you go back and you look to answer the question, and the question says how many teams are in the league. Well, we can't have a negative number of teams in the league. So we're going to throw out this equation. Even though it's a mathematical equation, it is not possible for the scenario of this problem. So the number of teams is 9. That's the answer to the question. Let's look at the second one. We've got a square. I'm probably going to have to erase. I need my space back. We've got a square field, so if it's square, all of its sides are going to be the same length. So we're going to let x and x be the length and the width of this square. And it says it has 5 meters added to its length and 2 to the width. So we have a longer rectangle now when we add 5 units to the length and 2 units to the width. Our new figure looks like this, and it's a rectangle. And it says the field now, so there's an important word. Not the original field, but the new field has a new area of 130 square meters. So we know area is length times width. 130 is equal to the length times the width. And we need to factor this. We need to go ahead and multiply. So we're going to have 130 double distribute is going to be equaling x squared plus 5x plus a 2x. So if you can do it in your head, you're going to end up with 7x plus 10. So that's all well and good. If you need to do the extra steps in here to double distribute it, take as much room and time as you need to satisfy yourself that you can get x squared plus 7x plus 10. We need this to be in standard form, so we're going to have to subtract 130 from both sides. So we're going to end up with this statement. And we need to combine our like terms. So our ultimate arithmetic process is going to end us with x squared plus 7x minus 120 equals 0. Now we need to use the AC method. Again, if you want to use the quadratic formula, you can pluck off A is 1, B is 7, and C is negative 120. If you can see the factoring, if you want to try the factoring first and you can't see it, then you can go back to the quadratic formula. But I always try the factoring first. So what do I see? I'm just looking for factors that make 120, 12, and 10, but that won't get me 7 in the middle. So that's not going to work. 5 will go in there. 5 and, what is that, 24? That still doesn't get me 7. What about 6 and 20? Nope, that doesn't work. What about 8? Yep, that's it. 8 and 15. And of course, now I have to look at my signs. So the 15, I need a positive 7. So, and I need a negative product. So one of these is going to have to be negative and one's going to have to be positive, and the 15 is going to be the positive one because my middle term has a positive coefficient. So when I set this up, it's going to look like this. X plus 15 and x minus 8. So now, of course, in order to solve for x, I am not on example 3. This was confusing me. So we'll back up here. In order to solve for x, I set each one of those equal to 0. Subtract 15 from both sides, and you get x equals negative 15 and x equals positive 8 for your 2 mathematical answers. But now, again, we go back up, and it's asking us to find the length of the original field, this guy right here. And, of course, we can't have a negative length. So once again, we throw out the mathematical answer that doesn't work in our word problem, and we answer the question that the original length was 8 in its meters. And that's the answer to the question. All right, we'll come back and do a couple more.